Okay, hi and welcome to some notes on 11.1, the section which we're going to be talking about simplifying radicals involving quotients and variables. So, let's get right into this rule. We have some other rules already that we've talked about, obviously like radicals and multiplying radicals as well. So we should have those under our belt. We'll probably employ a couple of those today after we deal with the quotient and variables part. So let's get down right to what this rule is. So what this rule says is if you happen to have a square root of a function, I'm not a function, I'm sorry, of a number, some fraction, that's what I was looking for. What we're able to do per this rule, the division property of square roots, says that we can actually separate them into two separate radicals, one being in the numerator and one being in the denominator. Very handy if we can deal with or simplify one portion of it and not the other. So that's really kind of what we're looking at here. Again, two things to note: that the a value is got to be greater than or equal to 0, meaning that we're not going to be dealing with negative values right at this moment. That's another rule and another conversation for a different video. And then two, we can't divide by 0. That doesn't make any sense generally, and it definitely doesn't make any sense here. So you can see from this quick example that you are able to split and then deal with these individually. But if you were to take 16 and divide it by 25, you're not getting a very pretty number, and you're going to be into some decimal version. And remember, in algebra, we prefer fractions for their exactness, right? We can avoid decimals as all possible. So a little play on words here. Remember that what's happening here is that we're splitting the square roots, and you can see that I've spelled out the word split and separated it. A little play for you there. But let's get right down to an example then. Looking at this first example, I've got the 11 divided by 49, not a pretty number, not going to give me a pretty fraction to deal with, and I can't simplify any farther. However, that being said, if we employ our rule, we are able to separate our numerator and our denominator so that they each individually are now square rooted. Exact same thing. Those are equivalent expressions. Now I can't do anything with the numerator here. Square root of 11 is going to stay the square root of 11. I can't simplify it any farther. There is no perfect square factors in there. But 49 does have a perfect square factor of 7 squared. And if you recall, when we do this, the square root and the square are inverses, which means that they are undoing each other. So they don't exist anymore. Hence the reason I'm changing colors and I'm scratching a line through both of them. They should not exist in my next step. So moving to my next step then, the square root of 11 stayed the same, but the denominator became just 7. That is simplified as far as I can take that particular problem. All right, let's try another one. This time let's include some variables. Again, the only thing that's different here is that they are variables, and we know how to deal with variables, especially with square roots, again, meaning 2, so they're going to be cut in half. So we're really looking for even-numbered square roots here, or I'm sorry, even-number powers on our variables. That's really what we're looking for, but we'll address that when we get there. So first, let's go ahead and employ the rule. So the quotient rule says that I can take and separate these into two square roots, one for the numerator, one for the denominator. All right, now that I have that, I'm going to start to look at these individually. I'm going to look at the numerator and see what I can do to this part here to be able to employ my square root rules, meaning simplify this as much as possible, and then additionally I'm going to look down at the denominator. So this becomes a couple problems in the same problem right now. So we're going to look at these individually. So the first thing I'm going to do is I'm going to notice that 25 has a perfect square term, right? It's going to be 5 squared. So I'm going to go ahead and change that. And this p value here, it's cubed. I need even values, right? Because for under square roots, they're going to divide. So I need to have an even value. So I'm going to separate that p cubed into the p squared and p1. Again, I've not changed anything. 25 is 5 squared. P cubed is p squared plus or times p1, which we add exponents when we multiply like bases. So that's the numerator part. Let's look at the bottom. It's already done for us. We have the square root of q squared, so it's set up and ready to go. Here's what happens then. This square root is going to cancel with that square. Again, this square root will also cancel with that square, but this p doesn't have anything to remove itself out. So essentially, it's staying under the radical where 5 and p are going to come out. Similarly, in the denominator, q will also come out outside of the radical because now it's gone. Whoops, grab the right one. So what we should be left with, and again, all under multiplication, you do not see any addition or subtraction signs here. So it's going to be 5 times the quantity of p, because that's what's left, and under the square root, again, multiplied, times p. The denominator will be just q. And if I look at this, there's nothing more I can do with my radical. There's no reduction out here in front with my coefficient or my variables, and so that one's simplified. All right, so let's look at one last situation. In this part here, I'm not going to show it, but in this part, sometimes it's actually easier to simplify underneath the radical before you separate it. And you'll notice here that 25 is divisible by 5. So what we want to do with this is that we want to go ahead and simplify it before we separate it. Not that we couldn't get there by separating it, but it's far easier, I think, to separate it with it being underneath the radical. So if we take 25 and divide it by 5, we're going to find out that 5 goes into 25 5 times. And then again, I'm done. I actually don't have to employ any more rules. So there is the notes portion for how this looks, dealing with the quotient rule and radicals, and even including some variables. All right, next will be a video on some examples, some additional examples I'll do for you to watch. All right, we'll see you in class.